Right, number 9. The diagram below shows the initial state of two identical balls, A and B, before collision, and the final state after collision. So initially, A is moving to the right at 3 meters per second. B is stationary. Then after an oblique collision, A moves at 30 degrees to the horizontal at 2 meters per second, and B moves at theta degrees to the horizontal at 1.5 meters per second. A says explain why the final momentum of the system in a direction at right angles to the initial velocity of A is 0. Hence determine the angle theta. Right. So initially the ball, as you can see, it's moving to the right, it's horizontal. It's not moving to the it's not moving in the perpendicular direction. So the initial momentum in the perpendicular direction to its travel is 0, because if you resolve the force P, that is the momentum, and say cos 90, that is perpendicular to its movement, it's supposed to be 0 because cos 90 is 0. Hence the momentum at right angles to the initial direction of motion of A is 0. Okay, momentum at right angles to the initial direction of A is 0. Now the initial momentum at right angles to A should equal to the final momentum at right angles to right angles to A. So 0, that is initial, should equal 2.6 sine 30 plus then also it's going to be minus here. Why? Because it's now going, this one is going down, it doesn't go up, so it will be 1.5 sine theta. So for the momentum, so you're going to have mass times velocity resolved is equal to mass times velocity resolved. Now sine theta will be equal to 2.6 sine 30 over 1.5, which is going to give you 0.866. Theta is equal to 60 degrees. Okay, so theta will be equal to 60 degrees as shown. Show that the total momentum of the system is conserved. Momentum in A's direction is equal to is given below. So initial is equal to final. So initially, that is in the horizontal, 1.2 times 3 plus 0, because the initial momentum of B is 0, should equal to final momentum, which is 1.2 times that cos 30, because we're now resolving in the horizontal. Both of them are going to go in the same direction, as you can see in the horizontal. So both of them add up, they don't subtract. Only in the vertical do they subtract, because they'll be moving in opposite directions. So you add the 2.7 plus 0.9, that gives you 3.6. 3.6 is equal to 3.6, hence momentum is conserved. Alternatively, the angle between these, we found it to be 60. So 30 plus 60 will be 90, and then you can form a closed triangle there, or you can find the resultant by using Pythagoras. So r squared is equal to 3.12 squared plus 1.8 squared, so that gives you 3.6 kg meters per second. The total momentum, we've found it to be 3.6 kg meters per second, so which means it is conserved. Now please do comment and ask for questions where you still need some further clarification, but I think I've done justice to all the worksheet problems. Signing out.